In the assignment today, you're just going to be using your knowledge of logarithms. So 382a. And I'm going to work some of the odd or some of the even problems in that first set. Okay, so 1 through 20 says apply the properties of logarithms to simplify each expression. So look at number 2. Log base 69 of what equals 1? 0. 69 to the 0 is 1. So that's the answer to number 2. What about number 4? Log base 3.3 of 3.3 has to be 1, the first power. Okay. Number 6, ln of e to the third. So ln of e to the third. Well, how would I simplify this? I put the 3 in front using the power rule. So I drop this down here, and I get 3 times the ln of e. But what is the base of the ln? E. So e to what power is e? 1. That turns into 3. Okay. Number 8, the answer is going to be 7. Number 10. What is the third root really? It's the 1/3 power. So number 10 is actually log base 5 of 5 to the 1/3, and that 1/3 drops out in front, and then log base 5 of 5 is 1, so the answer is 1/3. Okay, number 12. 2 to the log base 2 of 5, it's 5. 2 raised to the log base 2 just cancels, basically. It's a little more complicated than that, but the end result is 5. Okay, number 10. Or sorry, 14. It's going to be 3x squared plus 2x plus 1. Because the 10 log base 10 cancels. Okay. What about 16? So number 16, let's write it out. 7 times 2, or 7 raised to the 2 log base 7 of 5. What can I do here? I need to apply the power rule. The power rule says we can take the 2 out front and lift it up and make it 5 squared. And now this cancels that. And the answer is 25. Okay. Now, if you forget that, you can always convert to logarithm. So I'm going to put question mark over here. In logarithm, this would be log base 7 of question mark is 2 log base 7 of 5. So can I drop the logs in this case? Not yet. Once I move the 2 up, now I have log base 7 of question mark equals log base 7 of 5 squared. So question mark has to be 5 squared, which is 25. So if you ever get stuck in a logarithm problem, convert to logarithm or convert to exponent, depending on what you're looking at. And that will usually help you figure it out. And you may have to just put a question mark in there somewhere, but that usually makes the answer much more obvious. Okay, what about 18? I need to move the negative 2 up to the 10. And then e ln of e raised to the ln of e cancels, and I'm left with 10 to the negative 2, which is actually, it's 0.01 or 1 over 100. It's 1 over 10 squared. That negative exponent flips the base upside down, and we get 1 over 10 squared, or 0.01. And then number 20. Let me write that one out. Number 20 is negative 19e to the negative 2 ln of x squared. I need to take this negative 2 and make it an exponent. And I get negative 19e to the ln of x squared to the negative 2. Yep, I can cancel those. What is x to the x squared to the negative 2? X to the negative 4. So I end up with negative 19 times x to the negative 4, which is really... Sorry, where'd you get confused? No, because if that 19 wasn't there, wouldn't the answer just be x to the negative 4? So with that 19 there, this stuff is x to the negative 4, and then it's just negative 19 times. Right. And that's not really how it works, but that's the end result. So we're kind of skipping a bunch of steps, but basically it cancels and drops down. Although that's not a correct math explanation. That's just the result we have. And what is x to the negative 4? 1 over x to the 4th. So we get negative 19 over x to the 4th. That would be the answer to number 20. Okay. And then you're going to start doing all of the odds until 57. So look at 22. Can we expand 22? Yes. Are we going to get positive logarithms or negative logarithms? Well, they're both in the numerator. They're both positive, but I'm going to pull down those exponents, which makes them both negative. Well, no, it works. So let me do it in 2 steps. I would get log base 7 of x to the negative 3 plus log base 7 of y to the negative 5. That is the product rule. My two things inside the logarithm are on top, so the logarithms end up being positive, but the exponents are negative. 22. So we're going to drop this down, and we're going to drop this down, and I get negative 3 log base 7 of x minus 5 log base 7 of y. Because the exponents that I pulled down were negative. Now, let me show you another way to do this. What if I flip the x and the y to begin with? And I get log base 7 of 1 over x to the 3rd, y to the 5th. Now when I expand, what happens? They're both negative, and I pull a 3 out and a 5 out, and I get the same answer. Oh, it should be b. Sorry. Log base b. The base doesn't matter in this case, right? I mean, okay. 24. What are you going to get for number 24? The first one is 1/2, and the second one is 1/3, and both of those variables are in the numerator, so they're both positive. 1/2 log base b of r plus 1/3 log base b of t. Okay. 26, what are you going to get? 4 log base b of r, good. Minus 2 log base b of s. Does that make sense? Okay, skip to 32. How many different ln's am I going to have? Just 3. I only have 3 factors. X plus 3 is a factor, x minus 4 is a factor, and x plus 1 is a factor. The first 2 will be, the top 2 will be positive, and the bottom one will be negative. And I have to pull out the exponents. So I'm going to get 1/2 ln of x plus 3, and the parentheses are important in this case, plus 1/3 ln of x minus 4 That's what the factor is. The factor is negative. And then minus 4 ln of x plus 1. Does everybody understand that? Okay. What about 36? How many ln's will there be? There will be 4 of them. So we have a 2 out front to begin with. And then the first one will have a 1/3, and the second one will have a 4, and the third one will have a 1 in front, and the fourth one will have a 1/2. So you can either leave that 2 out in front and put everything on the inside, or you can double all of the coefficients on the ln. 36. And I'm okay with that. I'm not sure what Cynthia is going to do. No. But you'll have to do that on 35. So on number 33, does the numerator factor? Yes. Well, let's do 33, and then 35 will make more sense. So 33, does the numerator factor into what? The top. X minus 1 and x minus 1, so we're going to say x minus 1 squared, and we can put a 2 out front. Okay. Does the bottom factor? X minus 3 and x plus 3. So we'll end up with 3 logarithms. The first one will be positive with the 2 in front, and the next 2 will be negative. Okay. Now we look at 35. You put a 1/2 in front of everything. So 1/2, and then we have to check and see, do the top and bottom factor. Well, the top factors into x plus 5 and x minus 2. Both of those get a positive natural log. And then the bottom factors into x minus 2 and x minus 1. And both of those get a negative. But if I had an x minus 2 on top and an x minus 2 on bottom, so for 35, we would get ln of x minus 2, x plus 5, and then on bottom we get x minus 2 and x minus 1. Yep, so this cancels this, but we have to remember that x equals 2 is a whole. Right? Anytime you cancel factors, you end up with a whole. So really you only have 2 logarithms, and then you just have to remember that there is a whole. I'm not sure if she does or not. Look in the back and see if she does. It's not a huge deal on this, but later on, when you get to higher mathematics classes and you're solving something, you always need to remember that there is a whole, because if you end up graphing or getting answers later, you need to know that the domain had a restriction. Okay. So 37 through 47, you're just doing the opposite. You're going to put them together. And then 49 to 57, you're just using your calculator to find the change of base formula, using the change of base formula. So you're just getting the decimal answers. Okay? Piece of cake. Good luck.